the second method is effect of boiler pressure. Okay, the second method is effect of boiler pressure. Now, and dear students, boiler pressure is nothing but it is component in the boiler only. Okay, correct. Okay, now I will write here second method is effect of boiler pressure. And dear students, very important, little bit confusing, please try to understand. Okay, so effect of boiler pressure, so I will refer the same diagram here. It is boiler pressure, it is PB. So boiler process is between 2 to 3. So between 2 to 3 it is a boiler process. So the heat addition starts from this point and ends up to 3 dash if it is superheated. If it is only dry steam, it will end up to 3 here. Okay, so effect of boiler pressure. Now I will increase only pressure in the boiler. The remaining, the condenser pressure is constant as well as it is superheated only. Okay, now I will increase only pressure in the boiler. So I will draw one TS diagram for this. Okay, so TS diagram for increasing the boiler pressure, TS. Okay, so you refer the same block diagram. This is the block diagram for the Rankine cycle. Okay, so TS diagram, this is saturated liquid line. I will draw saturated liquid line, saturated vapor line, and dome shape structure. Okay, now I will draw 1 to 2, that is condenser, 1 to 2 pump. Now this is 1, this is 2. So 2, the boiler, that is heat addition starts. 2 to 3, I will take the different color, it will become easy for you to understand. 2 to 3 here, superheated. This is the maximum temperature in the cycle, that is superheated, 300. Point number 3, that is 800 degrees Celsius. Example I am telling you, in different power plants works on different temperatures. In some small scale industries it will go to around 300 to 400 degree. In large scale industries it will go to 800 to 900 degree, not more than that. Okay, again 3 to 4 expansion and 4 to 1 condenser. This is 4, 4 to 1, 1 to 2, 2 to 3. So dear students, 2 to 3 is boiler. 2 to 3 is boiler pressure from here to here. Okay, so this is at constant pressure, that is P1, or it is PB, boiler pressure, constant pressure. Condenser pressure I will not change, and I will not change superheated temperature. This is the maximum temperature. I should not cross above this line. This is the maximum temperature in the cycle, T max. If you increase the temperature of the steam above this line, so the turbine blades will not sustain. There is a failure of the turbine blades. So this is the maximum temperature, please you remember. Now I will change only this boiler pressure. Okay, for example, I will draw one more small diagram for understanding purpose. This is saturation. Assume this is a boiler. This is at 10 atmospheric pressure. Okay, 10 atmospheric pressure. Now you increase the boiler pressure. For example, this is one more boiler pressure. This is at 15 atmosphere. 15 atmosphere. So as the pressure increases, temperature also increases. So now I will increase the pressure. Effect of boiler pressure means I should increase the boiler pressure, not decrease the boiler pressure. So I will draw one line. Assume that this is at P1 pressure. Now I will draw one more line at P2 pressure. Just an example. 10 will become 15. So point number 1 will be remain same. 1 to 2 is pump work. So now I will increase to 2 dash. this is 2 dash. So the pressure is increasing, but it should stop at this point, that is 3 dash, because it is the maximum temperature. Now this 3 dash steam is entering inside the turbine, that is expansion takes place, that will become 4 dash, again 1 is common. I am not going to change this pressure is same, that is PC is equal to P2, that is condenser pressure. I am not going to change. So only I have increased the pressure. Earlier the pressure is this curve, assume 10 atmosphere, whatever may be, the pressure is increased here. So P1 dash, I will write, what is the pressure here, I will write P1 dash. P1 dash is the pressure. So P1 is initial pressure, case 1 initial pressure. So P1 dash is increased pressure, okay. And dear students, just you observe the area, the initial area is what, before increasing the pressure, initial area, I will start from this point, 1 to 2 is same because it is pump is same for both the cycles, 2, next 3, 4, 1. This is the one area 1. After increasing the pressure, where, boiler, after increasing the boiler pressure, what is the area 2, that is 1, 2 dash, 3 dash, 4 dash and 1. So this area is increased. So when the area is increasing, the work done is more, okay. That is one area. Or just as I told you, the curve or the area in the TS diagram below the curve will give heat transfer. Just now this example I explained you. Area below the curve will give the value of heat transfer. So now I will draw one more area here. Area not calling. This area, I will take this point A, this point B. So 4 area, here only I will write area 4, point number 4, 1 B A. 4 1 BA is when it is at initial pressure, P1, this green color line, P1. Now I increase the pressure to P1 dash. So what is the area now after increasing the pressure in the boiler? Area, what is the increase in the pressure in the boiler? So area 2, that is 4 dash, red color line. After increasing the pressure in the boiler, the steam which is coming outside the turbine is at point number 4 dash. So 4 dash 1 B A. And dear students, out of these two, which area is less? Area 2. This area is less than the area 1. So area A2 is less, means less heat rejected, correct or not? QR is less. So when the value of QR is less compared to A1 QR, correct or not? Compared to this area is less. The value of heat rejected, because it is condenser, the heat rejected is less, the QR is less, and the value of QR is less, 1 minus QR by QS, that is also efficiency. The value of QR is less, the ratio will be less, 1 minus lesser value will be the efficiency is higher value. Understood? This is effect of boiler pressure. And dear students, I will explain you once again. So effect of boiler pressure, here the pressure in the condenser is constant and maximum temperature is constant. We cannot extend the maximum temperature because So if you extend the temperature of the steam beyond maximum temperature, the turbine blades will be fail. So it is a harmful to the turbine. The manufacturing defects will take place. So that is the reason the maximum temperature is approximately 700 to 800 degrees Celsius. 700 degrees Celsius to 800 degrees Celsius, not more than that. Okay. So now initially Rankine cycle I have taken 1 to 2, 2 to 3, 3 to 4, 4 to 1. So here 1 to 2 is pump work, that is WP, and 3 to 4 is, that is green color line indicates it is work done by the turbine. Okay, here like that I will write work done by the turbine RMR. Okay, and 4 to 1 green color line, 4 to 1 is heat rejected, that is QR, and 2 to 3 the green color line, that is heat added, that is heat supplied. Now I will change only the boiler pressure. The first green color line indicates that is as 10 atmosphere. Example. Now I need to increase the pressure. So increase the pressure, why you are shown the curve above 10 atmosphere? Because pressure is increases means temperature also increases. Okay, so I have to take the curve above this first curve. So pressure is increased. So due to pressure increase, the second curve I have drawn here. So 1 to 2 is same. I am not changing 1 to 2 process. 1 to 2 is same. So 1 to 2, that is work done on the pump. So 1 to 2 dash, because I am increasing the pressure. If you stopped at point number 2, again it will become the previous pressure. So I don't want 10 atmosphere, I need 15 atmosphere. So I have to increase the line. I have to extend this point number 2 line little bit above, that is I will get 2 dash. So 2 dash is 15 atmosphere. The pressure is increased. Example I am telling you 10 and 15. Now the increased pressure is P1 dash. So due to increase in pressure, the point number 3 will shift towards left. Obviously, okay, 3 dash to 4 dash, that is expansion in the turbine. Again 4 dash to 1 is heat rejection in the condenser. Just to I have taken the area of one total area. Okay, area 1, 1, 2, 3, 4, 1. First curve, green color, 1, 2, 3, 4, 1. And this area I have taken only heat rejection area. Heat rejection area is 4, first cycle 1, 4, 1, B, A. This is much cycle, that is rectangular. 4, 1, B, A, only heat rejected. Similarly, area 2 for the whole cycle I have taken 1, 2 dash, 3 dash, 4 dash, 1. 1, 2 dash, 3 dash, 4 dash, 1. Only heat rejected area 4 dash. This is a new area, this is a new point after increasing the boiler pressure. 4 dash, 1, B, A, 4 dash, 1, B, A. This is area number 2. So area number 2 is looks less area than area number 1. So heat rejected is less compared to area 1 heat rejected. So efficiency, if the value of QR is less, then efficiency will be more. This is the effect of boiler pressure. Now the third last method is effect of condenser pressure. Third method number 3, that is condenser pressure, or it is also called effect of exhaust pressure. Why it is called exhaust pressure means here heat is rejected, that is called exhaust pressure. Okay, again I will draw one TS diagram. Dear students, it is very important, please try to understand carefully. TS, I will draw one saturated liquid line, saturated vapor line, and I will draw dome shaped structure. So 1 to 2 I will try a simple Rankine cycle again. 1 to 2, that is work done on the pump. Now heat supply is started. This is superheated. Okay, 2 to 3, 3 to 4. So 1 to 2 is what? Heat supplied. Sorry, 1 to 2 is work done on the pump, that is WP. 3 to 4 is work done by the turbine. 4 to 1 is heat rejected, QR. Where the heat is rejected? In the condenser. The condenser pressure is PC. I will take as P2. P2 is the heat rejection pressure, and P1 is boiler pressure, or PB. So up from 2 to 3, heat is added, heat supplied. Now, so in this third method, I am changing only condenser pressure. You will think whether I have to increase the condenser pressure or decrease the condenser pressure. I am not going to change the boiler pressure. I am not going to change the superheated temperature, that is maximum is maximum. I am not going to change. Only I am trying to reduce the condenser pressure. This is P2. Now I will decrease the condenser pressure to P2 dash. I will not increase. What I do, I will decrease the condenser pressure to P2 dash. So here is a P2. I will decrease now. Here I will bring this 4 to 1 line here. This is 4 dash. Earlier it was 4 here. This is the point number 4. So 4 dash to 1 dash. This is point number 1. So now 1 dash I will increase. I will stop here only. I will join this line. Okay. So why you are joining this line? The boiler pressure is constant. I should not change the boiler pressure. So 1 dash. This is 2 dash. This is 2. Okay. 1 dash, 2 dash. 3 and 4 will remain same. Now understood, dear students? Okay. So red color line indicates the first cycle, then the blue color line indicates the second cycle. Okay. So due to decrease the condenser pressure, there is a slight amount of heat is added, extra heat is added in the boiler. See, earlier the point number 2 is here. Now it is before that. 2 dash is here only. Understood? So extra heat is added to the cycle by decreasing condenser pressure. Or else, in other way I will explain you. You take area 1. What is the area for the red cycle before decreasing the condenser pressure? Area 4, 1. Now you take point number A and here point number B. So this is a one area. Now after decreasing the condenser pressure, area 2, so 4, 1, this is initial one. Now decrease the pressure, 4 dash, 1 dash. Now this is area. I will take A dash, and up to here it is B. P dash is not there. 4, 4 dash, B on the same line. Okay. So this is second area. So which area is more? Obviously this area is more. 4, 1, A, B. Just have a look. 4, 1, A, B area is more than 4 dash, 1 dash, A dash, B. So this area is less. So if the area is less, heat transfer rejected will be less. If the area is more, heat rejected will be more. So according to efficiency equation, 1 minus QR by QS. So if the value of QR is less, the ratio will be less. 1 minus less value, the efficiency will be more. This is effect of condenser pressure. So results, conclusion, what we do is conclusion. I will make one table. So efficiency, I will write here efficiency and parameters. Parameters are operating conditions. First point what I will write is superheating efficiency increases, and second one is effect of boiler pressure. Efficiency also increases, and last one, effect of, here I will write here, dear students, I will write here effect or decreasing condenser pressure or increasing the condenser pressure. The effect of boiler pressure means increasing boiler pressure. I will write here increasing boiler pressure. So increasing temperature here. Superheating nothing but increasing temperature of steam. Effect of condenser pressure is nothing but what? Decreasing the condenser pressure. Decrease condenser pressure. Decrease condenser pressure. So decrease the condenser pressure, efficiency also decreases. Efficiency increases. Efficiency increases. So this is what conclusion of these three cycles. Okay, so I will show you once again the first page number 1, page number 2, page number 3. So this is page number 1. So these are the topics we discussed today. These are three way of asking the questions. It is very, very important for exam point of view. It is asked many times as written here. So efficiency of the Rankine cycle depends on only two parameters. One is heat supplied, another one is heat rejected. So if the value of QR is less, efficiency increases. If the value of QS is more, even the efficiency of Rankine cycle increases. So on page number 2, this is only for understanding purpose. So there are three methods for increasing the efficiency of the Rankine cycle. For increasing efficiency of Rankine cycle, methods increasing efficiency of Rankine cycle. Okay, this is one is superheating. So in the superheating, what we do? Increase the pressure or increase the temperature or decrease the pressure? Obviously increase steam pressure, steam temperature. In the effect of boiler pressure, heat addition is more, that is increasing boiler pressure. Increase boiler pressure. Effect of condenser pressure is nothing but exhaust pressure. Here decrease condenser pressure. Decrease condenser pressure. So in page number 3, what we discuss, there is a third method. Sorry, here page number 3 is missing here. This is page number 3. This is page number 3 and this is page number 4. So page number 3, first one is superheating. This is superheating method first. Method 1, that is superheating. So due to superheating, only the temperature of the steam which is entering or passing to the turbine is increasing here. So this much of area is increasing, so efficiency increases. The second method, effect of boiler pressure. When you are treating effect of boiler pressure, condenser pressure is constant, we are not changing, as well as the maximum temperature of the cycle is also constant, only we are increasing the boiler pressure. So from P1 to P1 dash, that is what here we are done. And similarly, third method is condenser pressure, effect of exhaust pressure. Here we are decreasing condenser pressure. So condenser pressure is nothing but 4 to 1 process 4 to 1. So because of decreasing, again I told you here, I have explained already. So this is what conclusion. There are 3 parameters we are changing. One is superheating. For superheating, we are increasing the temperature, so efficiency increases. And effect of boiler pressure, effect means the whether boiler pressure is increasing or decreasing. So increasing boiler pressure, so efficiency increases. Effect of condenser pressure, is nothing but we are decreasing the condenser pressure, so efficiency increases. So thank you so much.